Okay, so hope you can all see my screen. Okay, so this is the data set about the information about the 50 startup organization. Okay, so you can observe. So you can see that how many different organization, 50 organizations there. So, and that gives the details about how much each and every organization spend. How much do they spend in R&D, and how much do they spend in administration, and how much they spend in marketing, and where is the state in which the startups are running, and what is the profit that is earned by the organization. So, and we are going to model a multiple linear regression that helps to predict the profit that will be earned by an organization according to the amount that is spent on research, the amount that is spent on administration and marketing, and the locality of the state in which the organization is running. Okay, so this is your coding for the implementation. Okay, so you all know that how do we do the import the data set, and after loading your data set we need to import the libraries that is needed to do the operation. So we need to, you all know that with the help of scikit-learn library has all the functionalities needed for your machine learning operation. Before that, you need to import the libraries such as your NumPy library in order to work on with arrays. This includes the functions for working on with linear algebra and fast Fourier transform and the matrices, and matplotlib for plotting, and pandas for to work on with your data frame. So once all your libraries are imported, the next thing is like we need to import the data set. You all know that we have the function called as read underscore CSV. So to this, we need to pass on your input file. Your file name is the data about the 50 startups, and the format is CSV. And then we need to have an iLocate function in order to separate between your input features and your labeled output responses. And x is going to be an independent variable. So according to the scenario, okay, so what is going to be the x? X, it includes all the column. Okay, so it includes all the rows and the features such as R&D, administration, marketing, and state. So exit includes all the features except the feature profit. So dataset.i location colon comma, what does colon comma represent? It includes, it has to read all the rows of the input dataset colon minus 1. Okay, so except the last column. So everything is going to be a x variable. And y is dataset.i location colon comma, it includes all the rows and only the last column, it's going to be our data set. So when we give the print x, okay, so we are able to visualize what is going to be our input data set. It includes all the features, amount that is spent in R&D, and then administration and marketing, and the state in which the organization is running. Okay, so and after that, okay, so your input data set is having a categorical data. So whenever there is a categorical data, okay, so ensure that your categorical data is converted into some numerical value. Okay, so for that we have the method called as column transformer. Okay, so column transformer is that helps to do one hot encoding. Okay, so from the scikit-learn library, okay, so in order to do the encoding of the categorical data, so from the scikit-learn library, okay, so we need to go to the compose method and we need to import the column transformer method. Okay, and then we need to do a kind of a pre-processing. Okay, so you all know that the computers cannot understand, so we need to make the data into a more meaningful manner. So for that, So we have a function called as pre-processing. Okay, and we are going to make use of the function called as one-hot encoding. Okay, so for that, what we are going to do, okay, so we are going to make use of the function column transformer. Okay, to this transformer, we are going to pass on two main parameter. One parameter is called as transformers, and the last one, the second parameter is called as the remainder. Okay, so this transformer parameter, it takes two other values as an input. One is what is the type of an technique, okay, whether it is encoding or decoding, it's going to be an encoding. They're going to encode your categorical into your numerical value. And what is the type of the encoding? We are going to apply one hot encoding. And then position, to which particular column position you are going to apply. So you're going to apply to 0, 1, 2, and 3. To the third column position, you are going to apply this one hot encoding technique. And the remainder is pass through. Okay, so what is the meaning of remainder is pass through? So we are not going to do any kind of transformation to the remaining of the feature. So which is going to be as such. Okay, so now we are going to do is we are going to, once this transformer is ready, you are going to fit this transformer to your input data set. So what is your x? X is this input data set. So to which particular column we are going to apply? We are going to apply it to the column in the third position. So once everything is done, okay, so we can run this so that we can ensure that your encoding of categorical data is done. Okay, so yes, you are able to observe that. Okay, so we see that though your data set is having state, okay, so and state is having three different state. One is New York, California, and Florida. Okay, so according to this one hot encoding, so this particular column is divided into three different column. Okay, so the first column is having 0, 1, and 0. Okay, so what is the meaning of 0, 1, and 0? So in the first column, wherever the value feature it is California as that alone is encoded as 1. Okay, and in the second column, okay, so wherever the feature Florida is there, that alone is encoded as 1. And in the third column, wherever the column New York is there, that alone is encoded as 1. Okay, this is according to the column transformer. So your encoding is done. So now your data set is pre-processed. Now it is ready. So now what you're going to do, you're going to split your data set into training data set and testing data set. So according to the complexity, according to the size of the data set, so for us, since we have 50 record, we have determined that is like test size as 20 percentage of the data set as test and 80 percentage as training data set. So from sklearn.model underscore selection, we are going to import train underscore test underscore split function. Okay, so what are all the values we'll get? Your data set will be divided into X train, Y train, X test, and Y test. So this train underscore test underscore split, it takes into four different values parameter, that is your X, Y, your testing size, and the random state will be equal to 0. So now your data set is ready. Okay, so the data set is divided into train and test. So now what we are going to do, now we are going to train the multiple linear regression model into the training data set. So whether it is going to be a linear regression or multiple regression, so the method what you're going to make use of it is going to be the same. There is no change in it. It is going to be the linear regression. So how we can do it? From sklearn library. Okay, so from sklearn dot linear model, we need to import the function called as linear regression, and then we need to call the function linear regression. So now the mathematical computation, that is like it's ready. So now what you're going to do, we are going to fit this linear regression model into the X train and Y train data set. Okay, so let me run it. It's ready. Okay, yes, it's done. Okay, so now your multiple regression model is now fit into your X train and Y train. And then what you're supposed to do, we need to do the prediction for the test data set. Okay, we need to do the prediction for the test data set. So that is like y pred is equal to regressor dot predict of x test. Okay, for the given input data set x test, we are going to predict what is the value. So what function we are going to use? It is regressor dot predict of x test. You can run, and we are also, we need to observe that, and we need to, the print option is set so that you are having the precision to 2. So we are going to consider only 2 decimal points places after the decimal point. We are not going to consider more than that. Okay, so this is your predicted value. Okay, and then what is going to be your y test is your actual value. Let us run this and see what is, how far your model is able to do the prediction. Okay, so y test is going to be your actual value. Okay, so the profit for some of the organization, if you look at your input data set, you'll be able to observe for what particular data set the profit is. So you can observe 103, 103. So we were not able to get locate the exact data set. Okay, so this is going to be our test data set. Okay, so this, and according to that model, we see that model has predicted the value as the profit for some of the organization as some nearly 1 lakh $15. Okay, and you see that, and this actual value is also 1 lakh and 282 not dollars, not much difference. And for some of the second organization, okay, so you observe that how the value is, it is like 1 lakh 44,000. Okay, so that is like 1 lakh 32 582, and the actual value is 1 lakh 44 259. Okay, so not a very bad prediction. Okay, so your model is able to do good, not much of varying difference between the actual value and the predicted value. Okay, so this is how we need to do the implementation for multiple linear regression.